Hello, happy Thursday. And as I kind of made a commitment to myself, yeah, after work I come home and I watch this abstract algebra lecture, just one lecture, which lasts like 45 minutes. And before I start recording this, so that's new routine now. And oh man, that's tough. That's the abstract algebra. It's like modern algebra developed in 1800s, 1900s. So it's not easy. And I guess I picked the wrong lecture series because it's done in Harvard. It's Harvard mathematics class. So those guys are smart. They're a lot smarter than me in terms of mathematics. So uh, so far I've watched what like four lectures by now, and I'm already lost. Okay, and but I'm kind of getting some general idea of what they're about. I think that should be enough for now. And probably after I'm done with this lecture series in a month or so, there are a lot of other group theory lectures, abstract algebra, modern algebra. So maybe I go for some easier lecture series because this one is too difficult. Okay, but I probably finish watching this series because it gives me some idea. Okay, although I don't understand every single detail of that, but yeah, I'm learning a lot. So um, we'll talk briefly about this row group that we named. Okay, row group, and then after that we'll talk about economics. Okay, because I want to take a break from mathematics. Okay, so by the way, I'm wearing orange pants, which I really like. Um, well, before we get into any of those things, let's talk briefly about politics, contemporary politics, because that's too easy, right? Compared to mathematics or economics. Economics is not as difficult as mathematics, but still, politics the easiest, right? Um, so like nowadays, this July 2019, the big topic in politics is the Mueller investigation of President Trump. Allegation is that he conspired with Russia to win election in 2016. Yeah, that's possible, and a lot of Democrats, uh, congressmen, senators, yeah, they made very good points. Um, Congress people, I mean. So, but the thing is this: did Russia influence United States election? Possibly, but what Democrats saying is Americans are stupid. They are Americans are foolish enough to be influenced by Russians when they voted for President Trump. So that's kind of insult and offense to Americans. So that's the kind of allegation, implication of this Democrats' allegation that Russians influenced American voting. Americans were foolish enough to be influenced by Russia to vote for President Trump. So that's an insult on America. So obviously Democrats they don't know what they're doing. They're insulting Americans. Okay, uh, so Democrats' theory is this: Russia, President Trump conspired with Russians so that Russian hack Democratic Party's private database and then revealed in the WikiLeaks some unflattering chatters within Democratic Party, and that's why Americans voted for President Trump. Okay, so President Trump basically assigned this task of hacking to Russians, and so that's the conspiracy theory. And President Trump made a lot of business deals with lucrative deals for his Trump organization, Trump company with Russia. Blah blah blah. I mean, it's a valid investigation. I'm not questioning that, but oh well, whatever. Just wanted to point that out. Okay, so and in terms of race politics, we didn't quite finish that discussion, right? Um, so it's basically inheritance. That's all it is. Okay, so American white people, they came to America, and over multiple generations, they in through inheritance, white people accumulated a lot of wealth, and at the same time they kind of exploited labor from African Americans back in the days of slavery. Again, slavery is just indentured servant. Okay, like it's not just America. Back in the days, it was like that in Asia as well. Asia, okay. It's all the same. Okay, they have this bonded servant, and it's caste system in India too. In Korea, China, Japan, they all had that. So there was no class upward mobility. If you're son of, for example, a, let's say, just noble, high class person in 1500s South Korea, okay, he's a nobility. He works in he's a government official or scholar, right? Then his children will be just that. And let's say he has this bonded servants who clean the house, housemaid, house servants, and their children will be also servants of this noble class people. Okay, it's just like slavery. Okay, so slavery isn't that unique. All right, so it just happened that those bonded servants they were sold against their will, and they are from Africa. Okay, so but bonded servant, indentured servant, that's what slavery is. Okay, it's an inherited class. You inherit your class. You're born with your class, and you cannot change your class. Just like you cannot change your gender or race. That's how it was back then in Asia, Europe, everywhere, even in Africa. Okay, that's just how it used to be. Okay. Now that changed, so you can change your class status by hard work, by education. But that's in theory. In reality, it's not that easy. Okay. And look at me. I was computer programmer, right? To become at least lawyer on paper, it took me almost a decade to go from programmer level to the higher class like lawyer level, lawyer on paper. Okay, so it took me almost a decade to achieve that. Money, I make a little bit, slightly more money than I used to as a programmer. Okay, not by much, but and also I used to live in an apartment. I used to be a renter. Now I own my house, right, all by myself, and it took me 4 decades. Four. Yeah, and but had I inherited a lot of money from my parents, grandparents, I guess if they are they were millionaire or billionaire, I guess they can just buy me a house, right, as a birthday gift, buy me a car, birthday gift, all paid for. If my parents had been war, should be like multi-millionaire, billionaire, or they can even give me a job, or give me a grant to start on my own business. That's President Trump, right, and his family. Yeah, family business, right? Yeah, I can inherit. If I were a billionaire son, like President Trump was, I can inherit wealth, job, company. Yeah, but for most of us, it's not like that. We have to work to. We have to own it. There's no inheritance for the rest of us, right? So is inheritance a bad thing? I don't think so. I don't think inheritance is a bad thing. I think inheritance is okay. All right. So that's where the so-called racial discrepancy. Black people, if you average their salary level, is less than white people's average salary level, right? It's because of the inheritance. Okay, so it's not like because white people hate blacks. No, no, it's not that. Okay, it's just inheritance. Okay, so that's the origin of this racial discrepancy in wealth and also crime as well. Okay, so it's not that white people hate blacks. No, it's not that. Okay, I want you to understand that. Okay, so all right, so and we'll do group theory later. Okay, so we'll do mathematics later. Let's talk about economics. Let's think about auction. Auction. Okay, there are two kinds of auction: auction and reverse auction. Okay, so in typical auction is like seller's market where you have one seller and you have multiple buyers. So the product that seller sells is very popular. So that's seller's market where in an auction you have this one item like Vincent van Gogh painting, right? And there's so many buyers, so they try to outbid each other. That's typical auction. Reverse auction is where let's say you come up with a product, nobody's buying it. Okay, so now you are. It's possible that you are the only seller, and there are 100 buyers, just like in a regular auction. But your product is so unpopular, it goes the other way. You lower your price. You lower your price more until you find one buyer who is willing to buy your product. Okay, so that's reverse auction. Or it's possible that there are many sellers and there's only one buyer. Okay, so sellers compete with each other to lower the price until this one buyer decides to buy that product. Okay, reverse auction. All right, so one more case. So in an ordinary auction, it's possible that there's only one buyer and there are multiple sellers. Okay, so no. Okay, multiple sellers, one buyer, and because opposite of there's one seller and multiple buyers, but product is unpopular, so this one seller lower the price more and more and more. Okay, how about this? There's one buyer and multiple sellers, okay? So sellers are the audience and one buyer is in the podium, he's the star of this he's on stage, right? And all the sellers in the audience, they are trying to sell this product to this buyer. They're all same product. So this buyer, one buyer on stage on the podium, he really want to buy this product from any seller. So he will be like, oh, I want to buy this product for $10. Anybody want to sell this product for $10 for me to me? Nobody. Okay, how about I raise the price? $15. Anybody want to sell your product to me for $15? No response. Okay, $20. How about that? Okay, I will sell my product to you for $20. Sold. Purchased. Yeah. Okay, so yeah, there are four cases. Okay, so all right. So this group theory. Okay, so you just want to do one very simple thing. Okay, so right now I don't know why group theory would be very useful because I mean obviously Galois Abel in their proof they used group theory. They made group theory, right? So obviously it's something very useful. So that's why I'm learning, but I'm just going along with it. Okay. Because, of course, in physics, even in chemistry, perhaps in biology too. Yeah, group theory has huge application, many different sciences, engineering. So I cannot quite ignore that. So I'm kind of left behind because I didn't learn group theory. But I think it's time for me to catch up with other scientists, mathematicians. So I decided to learn it. Okay, so yeah, it takes some time, but I will learn it. And also Andrew Wiles in his proof of Fermat's last theorem, yeah, he used group theory, modern algebra. So I guess I should learn it. Okay, so I'm learning it. Okay, so it will take some time. So you have row group of order 4, right? Yeah, row group of order 4 is from 0 to 3, okay? And you define addition, okay? And that's row group of order 4, okay? So that's all it is. It's a cyclic group too. What's the generating element of this cycle? 1 and 3. Okay. Why? You add 1, you have 1 and you have add 1 plus 1, 1 plus 1 plus 1, 1 plus 1 plus 1. If this becomes 1, 2, 3, 0. Okay. What is it? It's just modulo 4. Okay. World. It cycles, right? 3 same. Okay. You have 3. 3 plus 3. That's 3 is equal to 2. 0 modulo 4, okay, or row 4. It's easier to say just row 4, okay. All right. Yeah, it's this row group. And the interesting thing is this: what's the identity element? Of course, 0, right? What's the inverse? 1 inverse is equal to is such that it is 3, okay, because 1 plus 3 is equal to 0, okay. 2 inverse is itself because 2 plus 2 is 0, right? 0 inverse is also itself because 0 plus 0 is 0, okay. Yeah. How about 3 inverse? Yeah, 3 inverse is 1. 3 plus 1 is 0. modulo 4. Okay, so that's what I have to say. That there was this one thing. How about row two? Row two is, so we have that, right? So it's a group. Okay, so yeah. Row two. Row two is like inverse of zero is zero. Inverse of one is one. Okay, so yeah, that's kind of interesting. That's all I have to say. Okay, so yeah, like oh, they talk about isomorphism, automorphism, homo what homomorphism or something. I kind of get the idea, but yeah, to me that's just enough for the first round. Yeah, I can restudy again, and next time around with some different lecture series. Uh, yeah, I will understand more because it takes some iteration, multiple. No problem. Because I'm kind of slow. Okay, so yeah. What else? Is there anything else to talk about? I think that's about it. I have a comment. I have full time job. I come home. I watch this one difficult lecture, um, and then I do this. So I'm kind of like exhausted, right? So um, maybe after we take a break, okay, and we'll talk a little bit about our formulation of what prime number function. Okay, we'll do a little bit of that. Okay, so yeah, because I don't have to. I don't need group theory for that. No, because I already found it. We already did, so we just need to. We don't need group theory for that. Okay, so group theory is something I do for fun because it's very interesting to learn about it, although I don't quite 100% understand it. I guess I understand about like 60 to 70% of the lecture, and that should be, to me, that's enough. Okay, time well spent. So, all right, take five. Okay. All right. we're still taking a break, okay? So. Ah, okay, we are back. Um, yeah, I think it's important to learn things, so that's why I decided to learn something new to me, modern algebra. I didn't want to learn it, but I think it's good that I learned those things. So, okay. So I did some yard work. So I have this hut where my the trash, it's not trash can, the bigger trash container, I guess. They're just feral cats. The other day I've seen some two cats having sex, male and female, of course. Kind of cute. Yeah, kittens, they're cute. But I don't know whether there are many cats or just one cat keep coming to that hut and poop there. So I had to clear that. That's what I did today after work. Uh, I was like digging this kind of dry dirt. So I got rid of that dirt because it looks like the cat likes that kind of like litter. So I got rid of that dirt so that they don't come and poop anymore. I was digging those dirt to collect those cat poops to put in the trash. In Alaska, people come to Alaska to dig up the gold, and look what I'm digging. Cat poop. Is that why I came to Alaska? No. But that's what I did today. Digging up cat shit. Cat scat. Yeah. It was something I had to do. So. Okay. So, let's define a new set. I mean, we have it's a review, okay? We've done this before, a long time ago, several months ago, possibly last year even. Prime number set of prime number top 10, okay? So, is x bar x is prime, x is less or equal one, x is between 1 and 10, okay? It could be 10, but an x is belong to set of all primes, okay? So that's that, right? So for example, n top 10, natural number top 10 is what? We are not gonna count 1, okay? Get rid of 1, okay? So 2, comma, right? Yeah, it's from 2 to 10, natural numbers. Prime is this, right? 2, 3, 5, 7. Yeah, using what? The sieve of Eratosthenes sieve, right? All we are doing is they have it, Eratosthenes sieve, it has this algorithm, okay? You circle the very first number and you cross out all the multiples thereof, and you circle 3, cross out all the multiples thereof, 5, cross out all the multiples, right? We are just, it's a good algorithm, right? We are just formalizing it into mathematical expression that is very very orderly. Okay, that's what we are doing. Okay, so has anybody done this before? Possibly. I don't care. I mean, we don't care. All right, so. All right. We have multiple of 2, right? Top 10 is what? 2, 4, 6, 8, 10. It's a subset of multiples of 2, but each element has to be 10 or less, okay? And you have multiple of 3, top 10, what? 3, 6, 9, and your multiple of 4, top 10 is 4, 8, multiple of 5, top 10, what? 5, 10, right? And multiple of 6, top 10 is 6, and that's it, because twice of 6 is 12, that's more than 10. Okay, so now we define mu. Just mu is proper multiple set. Okay, so it excludes the very first element. Okay, so mu mu 2 top 10 is equal to, just exclude the very first one, okay, then 4, 6, 8, 10. 4, 6, 8, 10, okay? Mu 3 top 10 is we don't put 10 onto the left hand side because this part is reserved. Okay, so right now mu 2 top 10 is same as 0 mu top 2 10, because if this is not 0 and 1, it's not 0 but it's 1, then it means uh, the set of numbers when divided by 2, remainder is 1. Each of them is less than or equal to 10. Okay, so yeah, it's row algebra kind of stuff. Okay, so okay. So M 7 top 10 is what? 7 is a singleton, which can be abbreviated as just 7. Okay, so okay, so a number 7 is actually a set of the 7 alone, singleton. Okay, so that's one way to generalize a number. Okay, we see number as a set of single element. Okay, so all right. So for example, okay, 7 times 5 is actually 7 set 7 times 5. Okay, is equal to 35. All right. We have done this before. Okay, but if you have 2,7 multiplied by say 5,8, we define this multiplication, set multiplication, as Cartesian product kind of way. It's 2 times 5, 10, 2 times 8, 16, 7 times 5, 35, and 7 times 8, 56. Okay, so that's our set multiplication. We dealt with this before. Okay, so all right. Okay, so probably this is something new. All right, it's a very useful definition. Okay, believe it or not. Okay, now mu 6 top 10 is empty set. Okay, because we don't have any other elements other than 6. All right, and 7 all the way to 10 is same. Okay, so okay. Okay. So we are going to find a nice handy dandy formula for this P10, P top 10, okay, using this mu, all right. Well, we need another whiteboard, right, to erase right there. All right. So. Okay. Gotta do what we gotta do, man. Yeah, I'm tired. But aren't you? Oh well, we are diligent. We are very well disciplined people, so it's alright. Taking care of business, working overtime, right? Yeah. Ah, boy. Okay, well, let's bring this board closer. Tripod walk. Alright. Good enough? Yeah. I really like these berry drinks. Okay, so it's fresh. I picked it like yesterday, right? And they look pretty too. And uh, this rose hips vodka drink, it tastes too much like perfumey or cosmeticy because it still have this rose petal taste in it. It's cool, but it kind of tastes like soapy. Tastes like soap a little bit. Okay, too fragrant, but it's good. Yeah, and rose petal is edible. Okay, but rose hips when it's ripe, it tastes like persimmon. Do you know what persimmon is? It's very common in Asia. Okay, persimmon. It's wonderful, wonderful. Persimmon is fantastic. Uh, I give you some business idea. Farming, because I'm a huge fan of farming. Okay, yeah, import farm persimmon. Okay, PERS persimmon. Per Simon. Okay, Simon says persimmon. Farm this in America. Okay, then you will make a lot of money. Persimmon. Yeah, you can grow this in American soil. Why? Because Korea they have a lot of persimmon trees. Okay, and American climate and Korean climate isn't that different. Yeah, Korea has four seasons. I mean, California doesn't really have four seasons, right? But other northern states do. So yeah, farm persimmon because it's fantastic fruit. Okay, and yeah, you can farm it in America. Okay, so yeah, persimmon, amazing fruit. So yeah, rose hips when it's ripe, it kind of has this texture of persimmon, high vitamin C. Okay, so oh, there's this fruit fly there. Whatever, dead one. It's not a fruit fly. It's some whatever small flying bug it may be. Anyways, so let's continue. Uh, let's just write down N10 again. Okay, so N10. Okay, I'm not gonna do comma. Okay, is I'm well. I just said Korean numbering. 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, in Korean 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, Korean number pronunciation is very efficient because they're all one syllable. Okay, like 1, 2, 3, 4, 0 is 0, 1 is 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. They're all one syllable. Okay, so beyond that, yeah, two syllables or more. But anyways, so what are prime numbers? Is this by Eratosthenes sieve? Uh, you just get rid of all the multiples. Okay, first multiples of 4. You get rid of multiples. Okay, multiples of 3. I mean, other than itself. Okay, so multiples of 5 other than itself. You get rid of that. Multiples of 6, well, other than itself, there is none. Okay, so we only need to investigate from 2 to 5. 5 is just half of 10. Okay, so that's the idea. It's a very simple idea. It's just formulation of Eratosthenes' sieve. Okay, so that's the whole idea. Very simple idea. Okay, so P top 10 is N top 10. Okay, I'm gonna write you what P top 10 is. Well, we'll do step by step. Okay, so and this is a lot easier than group theory. Group theory, oh boy, that's too abstract, metaphysical. I'm learning it. Okay, it's not too difficult, but it's a challenge. It's an uphill battle, so it will take a while before I master it. But I got nothing better to do. Yeah, actually, yeah, I'd rather learn Russian. But learning Russian, yeah, is more difficult than learning group theory because group theory lecture, yeah, at least I understand what, kind of understand what they're getting at. But learning Russian, that's even more difficult. Okay, so but I'm learning right now like Brazilian Portuguese, but my next foreign language to learn it will be Russian. Okay, because I do want to learn it. Okay, but it keeps me out of trouble, you know. Anything that's not underlined. Okay, so it's 2, 3, 5, 7. Okay, so what's that? You just subtract, set subtraction. You subtract n. You subtract all the multiples from n. Okay, so n10. I mean p10. Okay, is n10 minus mu 210 minus mu 310 minus mu 410 minus dot 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 minus mu 1010. Okay, so I gotta write a little bit more. You know what? Let's write it out, all of it. Okay. Good. We fit in that space. And from here on, these guys are all nothing. Okay, they're all empty sets. So okay. Actually, actually, I made a mistake there. Mu 5 top 10 is also empty set. Okay, so yeah, it's an empty set. Boy. But let's talk about N11. Okay, N11 is from like 2 all the way to 11, right? So 11 quotient 2 is 5, right? So uh, here 10 quotient 2 is also 5, right? You divide 11 by 2, what's the quotient? It's 5, okay? So in Euclidean division, all right? So, but here you have mu 11, 5. It's not empty set, it's 10, right? All the multiples of 5 except 5 itself, each of which is less than 11 or equal to 11, yeah, you got 10. But here, mu 5 top 10 is nothing. Okay, well, is it 10? Actually, it is 10, huh? Okay. I'm sorry. So yeah, it's not empty set. Okay. Good. Very good. So yeah, we have to include this guy. Some quotient, this top number quotient 2. We have to include that. Okay. So yeah, I'm sorry, this is not empty set. Okay, so from here to there, that's empty set. Okay, very good. Okay. By the way, I feel something in my trachea, this in air pipe. Is it lung cancer or trachea cancer? I don't know what it is. I feel there's something there, like when I cough or when I smoke cigarettes. But is it some kind of cancer? I don't know. I do diet and exercise. That's good enough. Okay, so yeah, I'm not too worried about it. It'd be funny if I get some kind of smoke cigarette related cancer. So I've been telling you, cigarette and alcohol is better than other kind of drugs like sugar, fat, marijuana, and because you need some addiction, okay? It's human condition. If you're addicted to tattoos, piercings, your Americans in 2019, they are addicted to sugar, fat, tattoo, piercing. They are addicted to marijuana, sugar, fat, tattoo, plastic surgery, right? That's America 2019. And all I've been saying is, alcohol and tobacco addiction there too is better than addiction to gayism, like LGBT, addiction to sugar, fat, marijuana, opioid, prescription drugs, plastic surgeries, sugar, fat, marijuana, tattoos, piercings. I have been saying tobacco and alcohol is better addiction than those brand new addictions. And if I get some kind of cancer from tobacco, that'd be funny. Whatever, I don't care. But that'd be hilarious, right? Uh, because people will be like, haha, All right, so this is same as uh, I mean, in yeah, this same as n10 minus union what k from 2 to 5. What is 5? Yeah, 10 quotient 2. That's 5. Mu k top 10. Okay, so okay. Yeah, that's the uh, set of prime numbers, each of which each of whose element is 10 or less. Okay, so the general case, yeah, put 10 as t top maximum. Okay, t t t t, yeah, then you have general formula for that. Okay. Mm-hmm. We can say this freely because I mean, you've said A, right, and set B, right, and this is A intersection B. Okay, set A, set B, intersection is like this. Okay, so A minus B is equal to A intersection B complement. Okay, so that's like this Pac-Man look like this lunar eclipse. That's A minus B. Okay, so this lunar eclipse kind of. Okay, Pac-Man, old arcade, old American video game. Okay, one of the very first. Okay, it's not Japanese, it's American video game. It came from America. Okay, the Japanese, they learned how to do it and they excelled America. Okay, so but video game is from America. Okay, so all right, so this A minus B, but we know this all the set of multiples is subset, proper subset of n, and mu. Okay, so you have n and m and then mu. Okay, they are subset. Okay, so n, m, mu. All right, they're strictly subset. Okay, so you have a situation where there's A, and then there's B totally inside of A. Okay, so that's why we can just subtract them and unionize them. Okay, of course there are some intersection between multiples of 2, multiples of 3. What's that? Yeah, multiples of 6. LCM, least common multiple. Okay, so that's the intersection between 2 and 3. Okay, so yeah, am I going too fast? Come on. It's a set theory. Okay, so if you know mathematics, this will be very easy to you. If you don't know mathematics, maybe these are all Greeks and Hebrews. Don't worry about it. It's not that important. Okay, so you can just skip mathematics if you don't want to do mathematics. Okay, totally fine. Okay, but if you kind of know mathematics, but not too much, uh, maybe it's some kind of uphill, but it's still surmountable. It's not insurmountable task. Yeah, then catch up. Okay, so we take a break and we'll continue. Right? Yeah. Okay. Yeah. one more thing before we go to break. Okay, so in this situation, more generic situation, when B is not a subset of A, uh, this absolute value symbol means the number of elements in this set. Okay, this is equal to okay. But when B is a subset of A, number of A minus B is equal to number of A minus number of B. Okay? It kind of reminds me of this isomorphism in group theory. Okay, so that's kind of what they do. Okay, so that's if you are crazy about group theory, if you are obsessed with group theory, yeah, that's one area to explore for you. But I'm not. I'm not a huge fan of group theory. I'm not. Okay. Because it's somebody else's baby. I didn't create group theory. Yeah, Galois and Abel did. By the way, I have to make some correction. Leonhard Euler is not German mathematician, although his name kind of sounds like German because in Switzerland, yeah, they speak German, French, English, right? Trilingual kind of country. But Leonhard Euler is Swiss mathematician, okay? So correction, he's not German mathematician. Gauss, Friedrich Gauss, yeah, he's German, but Euler is Switzerland. He's Swiss. I recently learned from watching all these YouTube videos. Okay, so yeah, it kind of reminds me of this what not isomorphism, but is it homomorphism or isomorphism? Homomorphism, I guess. One of the two, most likely homomorphism. Okay, like f x operator one b is equal to f operator f a operator two f b something like that. What? It's all just some linear operator, linear combination kind of thing, like fx plus y is equal to fx plus fy, kind of like distributive kind of thing. Okay, so abstract algebra, yeah, I keep learning because it's something really cool. Okay, I like it because it's very abstract, very metaphysical. They try to find some common pattern, uh, which is I'm kind of interested in. Okay, so I keep learning. Okay, because I think it's good mathematics to learn. Okay, so and it teacher said you can tell a tree by its fruits. Modern abstract algebra, yeah, it was useful to prove Fermat theorem and this polynomial impossibility kind of stuff. So, and also it's being applied to physics, chemistry. I don't know how useful that is actually. Maybe just kind of show off their mathematics skill. I don't know how practical it is in physics and chemistry, this group theory. I don't know, but at least it's theoretically very beautiful, okay, mathematically. So I keep learning, okay. So let's take a break, okay. So okay, so that's that, all right. Yeah. Yeah, there's some group theoretical stuff here, so whatever. I'm not crazy about group theory. Okay, yeah, I'm not. Take five, okay. Okay. Uh, so there was this one thing I wanted to talk about. I forgot. Totally non-mathematical. Um, what was that? I don't recall. Uh, well, whatever. So let's talk about this lecture series that I'm watching. Okay, so there's this teaching assistant. guy. He's not white guy. He's probably some Middle Eastern, possibly a Jew, or I don't know. But I like him. Okay, he's very energetic. You know, obviously a Harvard mathematics PhD student for this Jewish professor, I think. Okay, yeah, but I like him. He's very smart, and I'm all these students in this Harvard University, very smart, smarter than me when it comes to mathematics, in a sense. Okay, yeah, but at least they're not as nearly as creative as I am. So, hey, I don't know as much mathematics as those Harvard mathematics students, but did they create theories? Did they discover anything? I don't think so. I don't know nearly as much mathematics as they do, but in a way, I am better than them in mathematics because I'm discovering brand new things. Okay, so I'm more like laid back, kind of creative kind. I mean, Abel, Galois, they didn't go to Harvard or Cambridge or whatever top school of their country like Norway or France. Just bunch of punks, young, young and dumb people. Yeah, there are a lot of sympathy going on of all this Mozartan kind of prodigy, right? Yeah, they died young and they were very smart, so people have sympathy for Ramanujan, Abel, Galois, just because they were smart and died young. I'm not gonna die young. No, I live long age. Well, unless I hope I do. Unless I get some kind of cancer from cigarette smoking. Whatever. Okay. There's one more thing that I wanted to talk about. Totally no mathematical, but I forgot. Okay, probably come back to me later on. Okay, so we can erase all this. All right. So yeah. When B is a subset of A, okay, yeah, you can distribute this absolute value operation. Okay, it's like, yeah, in group theory they do something like this. If f of x, some operator y, it is f this function operator's function. Okay, and then you have some outer function. Okay, it distributes some operator is operator variable. Okay, it could be plus, minus, whatever. Okay, what's the easiest example of that? Let's say e- let's say f function f. Okay, okay, let's do this. F of k is defined as c times k, c multiplied by k. Okay, so c times k, that's definition of function f. Okay, and then for example, and we say this operator variable is plus, which is a function. Okay, circle here is operator variable. It can be multiplication, plus, subtraction, division, whatever, binary operator. Okay, so and in this particular example, okay, circle, let's say, is variable for a function. It's a function variable. Okay, it can be any function, but it has to be binary function. Okay, because function can have any number of inputs, right? But if it has two inputs, that's binary function. Okay, so this circle operator is a binary function variable. it's a function variable. It can be any functions as long as it has two inputs. Okay, so all right, so f of x plus y is c times x plus y, right? And it's distribution, right? So this is c times x plus c times y, which is equal to f of x plus f of y, right? In group theory, they talk about this. I think it's called homomorphism. Okay, that's from what I remember. Okay, isomorphism is a subset of homomorphism that kind of preserve the structure. Okay, like structure preserving homomorphism is called isomorphism. Okay, that's what I remember. Okay, so yeah, I'm learning something. Okay, because abstract algebra, yeah, I like it. Okay, so looks like it's very useful and true. So okay, so but that's just beside this. It's a side story. All right, so yeah, it is when B is subset of A looks like it's kind of like homomorphic relationship. All right, so because this absolute value operator is kind of distributing. You have two operators, two functions, absolute value and also minus. Okay, and absolute value operator is distributing over subtraction operator, just like multiplication operator is distributing over plus addition operator. Okay, so that's how they call it in group theory community, homomorphism. All right, any function that satisfies this kind of distributive property. Okay, so oh well. Something I noticed. Okay, so should I take a picture of this? Maybe. Okay. The least I can do. The least I can do. Yeah, I take a picture of it. Alright, smile. Smile. Alright. Now we can partially erase all this irrelevant stuff. I mean, we don't need to do group theory here because group theory, at least so far, we don't need it. Okay, I'm learning group theory just because I want to learn something because I'm just bored of doing the same thing. I want to learn something new. It's like metaphysical eating, consumption of knowledge. Okay, absorption and what assimilation of extraneous elements like group theory, which is very new to me. And it's not too new, but I didn't know much about it, so yeah. It's like eating food, okay? Yeah. Consumption, assimilation, okay? So digestion, it become part of you, kind of. I think group theory is a Holy Spirit, okay? I think it's good. I think it's clean. Okay, I don't think it's dirty. Okay, so yeah, then it's clean. Yeah, we'll eat it. Meaning learn it. Okay. All right. Uh, so pi, c- prime counting function, pi of n, prime number counting function. Okay, n top, let's say t. Okay, the top number upper limit. Okay, it's just absolute value, which is the number of elements in this set. That's it. Uh, Wait a minute. Actually, this is t. Number of primes, each of which is less than or equal to t. That's the prime counting function. Okay, that function was defined long time ago. Okay, so maybe by Euler or Gauss, I don't know. Okay, so what's that? It's nt, absolute value of nt, minus uh, union k from 2 to tq 2 mu k t, which is same as because all these sets are subsets and these mu's, and union of that, there's still subset of n. Okay, so this is same as uh, nt, absolute value, minus absolute value of u k from 2 tq2 mu k top t. Okay, should we do proof of this? Maybe. Okay, we gonna need another whiteboard, and we'll do the proof real quick. Maybe we need to take a break, I don't know, or maybe we can just do it right here. We'll try. Okay, so proof B is a subset of A, meaning, and then A minus B is equal to A minus B, absolute value. Okay, prove that. Okay, so proof. I think it's easy. A minus B is equal to A intersection B complement is equal to because B is a subset of A intersection B is B. QED. Okay. Left hand side, right hand side. Okay, so same. Yeah, that was easy proof. It's the set theory. Okay. We call it set subtraction distribution theorem. Okay, set subtraction distribution theorem. All right, so let me write that down. Okay, in my notebook. Yeah, because it's kind of important. Okay, so it's been a while since I wrote anything down. My notebook is paper and pencil. Okay. Two-line proof or one-line proof. Very simple proof. Good. Now we'll take a break, okay, and then we'll do this, okay. So this guy, okay, it will involve some LCM, least common multiplier, which won't be too difficult, okay. So all right, we'll do it, okay. We got time. Take 5 minutes, 10 minutes, whatever. Yeah, I gotta start cooking my dinner though. So You're still on break, okay? So I just came to grab my cell phone. So yeah. Okay. So what am I cooking for dinner? Well, I'm boiling eggs because I love boiled eggs. Oh, it's like pure protein. Yeah, I mean egg yolk. Well, by the way, we're gonna switch out this board. Okay, so well, egg yolk. It has a lot of fat in there, but if you compare egg yolk and egg white, egg yolk has more protein than egg yolk. Yellow egg yolk has more protein than egg white. Okay, and it also has more fat in egg yolk. Egg white, it has some protein, but it has no fat almost. But egg yolk, egg white has a lot of protein, but not almost no fat. That's egg white. Okay, so but egg yolk, yellow part, it has a lot of more protein and also a lot of fat in there. Okay, so uh, eggs that cheap. So some people just eat egg white, not egg yolk. Okay, but me, I cannot. I used to do that for a while. I mean, for some couple of weeks, but I didn't quite want to waste egg yolk because it also has a lot of protein in there. Okay, so and other good stuff. So nowadays I just eat them both. Okay, so it's kind of pretty, but I took a picture of this, right? So yeah, I take a picture again because it's kind of pretty. Just because it's pretty, okay? It's like very pretty. Definition of group. Okay, so now I can erase this. Boolean definition of group. A group. Okay, so it's kind of cool. All right, so uh, let's go back to the basics. Okay, set theory. Okay, so it's like this. All right, so you have set number of set A union B union C, right? Is what, right? Uh, okay. Well, that's a good starting point. Hey. To do this, we gotta expand horizon. All right. So, um, let's expand horizon by n20. All right. N20. All right. All right. So, M220 is two. M320 is, I'm sorry, getting ahead of myself. Okay, so which is equal to, okay, and what is 6? 6 is the least common multiple between 2 and 6. Okay, we just write it as 2L3. Okay, least common multiple of 2 and 3. All right, so yeah. We're not gonna even do 3 things, right? And at this point, okay, we'll just do 2 things. Okay, so forget about 3 things. Just to deal with 2 things, one step at a time. Okay. AB is A intersection B. All right. So all right. So we have multiples of 2 and multiples of 3 and multiples of 6. Okay. We don't like multiples, right? Because they're composite numbers. They are like dirty, all right? Prime number is pure, it's clean. So we want to only collect the pure element, prime numbers. All the composite, this mixed stuff, we want to get rid of that. Okay, so like refinery of metals, okay, gold, silver, copper, iron, aluminum. They are useful because they are pure. All right. Again, I'm not being racist here. Okay, so if you're mixed race, I'm not against you. Some of my best friends are mixed race. Okay, so it has nothing to do. Nothing. We are not racist. Okay, so we're just dealing with numbers. I mean, you use iron, aluminum, right? Because they are useful because they are pure. Of course, you have alloy. You mix 2 different metals, pure metals. Okay, yeah, I get that, but we are not doing metallurgy here. Okay, we are doing mathematics. We want to get rid of composites to extract prime numbers, pure, clean stuff. Okay, this is mathematical refinery right here. Okay, that's what we're doing. Give me 1 second. Okay. Just boiling my eggs. Okay, so a score of eggs, maybe a dozen. I guess just a dozen eggs. There's this art in boiling eggs, right? You don't want to fully cook it, or you don't want to undercook it. You want to kind of be in the middle, so that the egg yolk is kind of like caramel, kind of caramelized egg yolk. Oh, they're so good, aren't they? Yeah, the egg whites are fully cooked, but egg yolk is like half cooked. That's the best boiled eggs. I'm trying to make that. Okay, it's tricky. It requires a lot of attention, right? Doesn't matter. It's not that important. Kind of, yeah, the happy middle, the middle of the way. Aristotelian, Aristotelian egg boiling. No, don't undercook it, don't overcook it, just in the middle so that egg yolk is kind of like caramelized, kind of like marshmallowy, kind of. Okay, this is not modern algebra. Okay, it's not no group theory, no field ring theory. No, it's just plain, set theory, which is kind of modern in itself. But it's a lot easier than group theory, field ring, this abstract algebra. No, it's just set theory. Okay, so because even in early 1900s, there were some prominent mathematicians that were kind of resisting this set theory. Okay, like Kronecker or some philosopher like Wittgenstein, or was it Kronecker or Christopher? I don't know. A lot of mathematicians resisted this set theory. It's kind of new and something extremely powerful. Yeah, but I learned this since when I was in middle school, so yeah, it's not new to me. So okay, cucumber berry vodka. Oh, so pretty. Mm. That's so special. I mean, forget about top 20. Okay, just let's just simplify. Okay, so M2. This is red. We don't mix red and black. Okay, so we just don't. All right, it's satanic combination of color. Okay, so we just know M6 is equal to M2 intersection M3, right? Multiples of 2, and also it's multiple of 3, and then it has to be multiple of 6, right? Yeah. So in general, multiple of A intersection multiple of B is same as um, multiple of A L B. Okay, so least common multiple between of A and B. Okay, so if B happen to be multiple of A, then it absorbs. Okay, so A L A K is A. That's kind of absorption rule. Okay, what's the least common multiple of 2 and 4? Least common multiple. Oh, I'm sorry, this is AK. Okay, yeah, that's Least common multiple of 2 and 4 is 4, right? Okay? So, uh, and then, yeah, so this can become like M A K M B, right? So, yeah, I gotta turn off that boiling egg, okay? So, because I don't want to overcook it, you know. So, alright. Alright. Phew. Okay. And one more thing, alright? One more thing. Is absorption rule, okay? So, let me write this down. Absorb, how about absorption theorem? We're not gonna bother proving it, okay? It's just too obvious. Okay. This we call it intersection theorem, okay? Just because it's intersection, and we are not going to even bother proving it, okay? So it's too obvious. All right, we keep erasing this lower part because we need to refer to this table here. Uh, this button can go up there. We don't need it. All right. I don't need two pens. So, how much time do we have left? It's time to take a break. We'll go to break very soon. Okay. So, one more thing. All right. Um, we did this before, so it's a review. Okay. For example, how many multiples are there of two are there in 20 or lower? It's 10, right? Yeah, 10, which is equal to 20 quotient 2. Alright? In general, you have top, the upper limit, right? And then you have multiples of let's just say A. Okay, so that's T quotient A. Okay? So we have that. Okay. So do you see where we are going with this? It's this, right? So 20 m m2 top m2 top 20, all right, intersection m3 top 20, okay, and that is equal to m 2l3 20. Okay, so it's like factoring it out. M20 is repetitious, right? You want to write this only once, okay, and this intersection becomes L. It's like it's like C times A plus C times B. You factor out C because you want to write C times only once. It becomes C times open parent A plus B close parent, right? Factoring it out. We want to do the same thing. You have M top 20, M top 20. You factor it out. What's left? 2 intersection 3. It's like 2L3. So intersection becomes L. Least common multiple. Okay, so that's, I mean, in general, we gotta do is substitute some alphabetical letters for these concrete numbers, right? So you have T, M, A. Okay, so we gotta name this thing. Hey, this intersection theorem, right? You just how about absolute value is also called cardinality of set. Okay, so intersection cardinality theorem. How about that? Okay. Yeah, it's very distributive. What does that remind us of? Yeah, homomorphism in group theory. Okay, very distributive, but we don't have to go there. Okay. Because I'm not crazy about group theory. I've seen some people crazy about group theory. Okay, they try to think everything in mathematics in terms of group theory. I'm not one of them. Okay, I'm learning group theory just because I think it's interesting and useful, but I'm not idolizer. I don't. Group theory is not my idol. Okay, I'm not idolater of group theory like many mathematicians nowadays are. I'm not one of them. Okay. No. By the way, Bible God, Jesus, they can be idols if you blindly believe in them. Okay, so in humanology, we criticize them. We don't blindly believe in them. Okay, we rationally analyze God, Jesus, Bible, Holy Spirit, and we try to understand them rationally. Okay, we don't idolize God, Jesus, Holy Spirit, Bible. We don't. Not here. Not in humanology. Alright, so. We don't do any idolatry. Okay, we are not, because we are not blind. We are rational. Okay, we can see. We are the last people on earth who can see things clearly. Okay, we are the last survivors of rationality because we are humanologists. Okay, so I know I sound like occult religious leader, but hey, I don't want your money. I don't want your wives, your girlfriends, your daughters. No, I'm not that. Some of those cult religious leaders, I got my job, okay? I don't need your money, okay? Keep your money. Oh yeah, there was this thing I wanted to talk about. Yeah, if I ever win this Bill's conjecture money, $1 million, I'm not gonna take it. I will give it back to this Fields Medal, this trustee of that Bill's scholarship fund, $1 million. Yeah, so that, yeah, just I talked about this before yesterday. Just use this $1 million for the next conjecture to be proved, so that you keep on inspiring next generation of mathematicians. And I recommend next generation mathematicians to follow suit, to follow the lead of me. Okay, my leadership. Yeah, you prove this, give it back to the committee, the Fields Medal committee, so that just pass it on. Don't take it to yourself. Just like Frodo in the Lord of the Ring. Oh, the ring is mine. No, don't take it to yourself. Okay, just keep on giving, pass it on. Yeah, be like Jesus. Give rather than take. Serve rather than be served. Administer rather than administered. Be like Jesus. Okay, so yeah, anti-mammon, anti-money kind of self-sacrificial kind of thing. I think that's more beautiful than just taking their money, right? So that's what I would do. Okay, that's what I would do if I ever prove Bill's conjecture. Okay, or disprove. But I think it's probably true. Bill's conjecture. Kind of smart guy. So, very nice person too. Okay, philanthropist, educator, inspirer. Yeah, he's a good role model, Mr. Bill. Okay, Midwestern American banker. Yeah. So not every rich people are bad. Okay, so they're good rich people. Okay, let's take a break, and we may continue or we may finish. Wrap it up. I don't know. Let's take a break. Okay, let's see what happens. Okay. Oh, my glasses is over there, so I guess we'll just continue. Okay. Exercise some diligence. Tomorrow is Friday, so happy Thursday. Yeah, we can work overtime, I guess. By the way, did I write that down? This guy. We call it quotient theorem. Okay, quotient theorem. Quotient theorem. Too many theorem. Okay, we are like power factory, mathematical powerhouse right here, man. We're spinning out theorem after theorem. Theorem is mathematicians' product that they sell. Okay, so we are making a lot of mathematical products, theorems. This quotient theorem. Okay, so yeah. All right. Now, so let's make some concrete example. Okay, so how many multiples of 6 are there in this set 20? We call it set 20. Okay, so I'm getting cold, so I better turn on the heater. Put on my sport coat. Okay. By the way, a communication, conversation between two people is a copium transfer. Okay, sometimes you give them copium by showing them love, and sometimes you take their copium by showing them some discipline. Okay, so that's communication. Pain and pleasure. Okay, so like being contrary or being agreement, being in agreement, agreeing or disagreeing. Okay, copium transaction, copium transfer. Okay, one two-way street. Copium go from you to the other, or copium comes from the other to you. Okay, agreeing, disagreeing. Okay, so yeah, two-way street of copium transfer, right? So all right. So we said 20 M2 union M320 is equal to M220 plus M320 minus M620. Okay, let's see if this is true. Okay, so this is what you have, what 20 divided by 2 was the quotient, 10, plus 20 divided by 3 was the quotient, 6, minus 20 divided by 6 was the quotient, 3, 13. Well, let's see. What is M220 union M320? Well, let's see. 2, 3, 4, 6. These two lines, okay? Combine it. 2, 3, 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, 20. How many are there? Yeah, it's certain. So, yeah, this formula is correct. Okay. But we have to do mu. Mu. Okay, so that's the key. All right. So we just verify this in one example through one example. Okay. So now we have to convert this m to mu, and we'll call it mu theorem or m mu conversion theorem. Okay. It's a lot. Yeah, it is nothing advanced. It's something very elementary and trivial, but there are a lot of this. Okay, but it's kind of important. All right, so just bear it with me. Okay, so you have 20 mu 2 is equal to absolute value thereof m to 20 absolute value minus 1. Okay, so that's that. This mu m conversion theorem. Alright, so in general, t mu a is absolute value thereof is equal to m. This is mu. Okay, so at minus 1. Alright, so because you're getting the very first element, you just want pure multiples, not itself, but multiple of that number. Okay, so that's why you subtract 1. Okay, so M mu conversion theorem. Alright. They're self-evident, so we are not gonna bother proving it. Okay, so we just leave it as exercise, homework. Okay. All right. Now, how about mu 2L3 top 20? What would this be? This we may want to prove because it's not that trivial. Okay, so what would this be? I mean, 2L3 is 6, right? How many are there? Well, there's 3. No, actually, that's 2. So you have what, 10 here, 6 here, you have 10, you have 6, right? So my guess would be this is like 20 quotient 2. Well, let's not get too much ahead of ourselves. We are getting too much ahead of ourselves. Okay, so M 20 uh, 6 is equal to, well, okay, so M22 union M320 is equal to M220 plus 320 minus M620, right? See what? 20, this is 13, right? So 20 plus 6, wait a minute. 10, right? I'm sorry. 10 plus 6 minus 3, right? Okay. Hmm. So M220 and M320 is like mu 220 plus 1, and then mu 320 plus 1. That's why mu 620 has to be plus 2, so that plus 1 minus 2, they cancels out and equality is preserved. Okay, so yeah, that's like there should be like M 2L3 20. Is it minus 2 or plus 2? Let me see. Minus 2. Alright, so we will try to prove it, okay? So after a break. Alright, so in general, mu ALB T is equal to M ALB top T minus 2. Uh, well, absolute value thereof. This is not very trivial, so we'll try to prove this. Okay, in another whiteboard. All right, so because this is not trivial. Okay, so it's not difficult. It's but just on one level higher. So we'll prove this. Okay, so we have to name this, right. So we call it mu M mu L conversion theorem because we have L here. We will of course make use of previous theorems. Okay, so but we we switch out the whiteboard and we go ahead and prove this. Okay, so it's been a while since we proved anything. So again, this is not some abstract algebra ring group field. So I don't know much about them. Okay, it's just set theory, LCM. Okay, so it's nothing fancy. Okay, it's nothing Harvard. No. All those Harvard people, geeks and nerds, right? They're impressive, but I don't want to be there. They're too hardcore. Okay, they're too specialist. I'm more generalist. Okay, so I don't want to do too much mathematics. I want to do politics, mathematics, economics. I want to do everything, alright? So martial art, dancing, foreign languages. Okay, take 5 to 10 minutes break. Okay, so all right, we'll switch out the board, but not now because I want you to stare at this. Okay, yeah, get ahead of me. Be inspired. Come up with some proof before I do. Yeah, try to prove this. Okay, before I do. So yeah. Okay, take 5. Or continue if you'd like. Right. I need a break if you ask me. So I'm not Harvard. I'm laid back. Okay, so I'm no elite. I'm slow too. Okay, so all right, take 5. Okay. Let me put my socks back on. Because it's kind of chilly. Oh yeah, we gotta switch out this whiteboard, huh? Okay. Well, I'm gonna keep the windows open because there's stuff in here. I got tuck in my shirt because sorry. I do this often, okay? Tucking in my shirt into my pants. Yeah, I do this very often. Alright. This guy. Past failures comes in handy because we can erase these boards, right? Yeah, I kind of living like a hermit in a sense. Alaska, I'm doing mathematics in isolation, but Andy Wiles, he was kind of, yeah, he was in Cambridge, Oxford, Princeton, but he worked on this proof of Fermat's last theorem in isolation, kind of, okay. Galois, he did in isolation. Einstein, isolation, okay. It's like one on one with Holy Spirit, God, Jesus, kind of isolation, okay. So I mean, at least I kind of imitate, okay. So working in isolation, right? So that we don't get distracted, all right. So okay, just like Jesus said. What? Jesus said like, yeah, if you're gonna pray, pray behind the close quarters. Don't show off. Just pray when nobody see you. Pray. That's what Jesus said. Pray in humanological interpretation is labor, no matter what you do. Okay, so praying in isolation, kind of. Yeah. All right. So proof. Mu t a l b m a l b t absolute value minus 2. Well, that's right hand side. Okay, so left right proof. That's what we do here. Right. Left is same as right hand side. Yeah, it's a proof technique, handy dandy. As I learned in Korean high school. Okay, so one thing about Korea and Japan. Okay, did Japan contribute to modernization of South Korea or just yeah, South Korea? Yeah, I think so because Korea also modernization of China too because China and Korea we had our pride, right? Chinese Koreans, they had their pride, so when they saw the superior Western civilization, they resisted. They didn't want to admit that West, white people, they are superior to Asians, their own culture. So they resisted that because they have ego. But Japan, they were the first one to admit the superiority of Western civilization. Okay. After that, they saw China and Korea kind of resisting, and they beat the shit out of China and Korea. Okay. To teach them a lesson that yeah, you have to accept this superior, modern technology of the West. So they did contribute to the modernization of China and South Korea. Okay, North Korea, well, that's a different story, right? But let's give them due credits. Okay, so because in humanology we tell the truth, whether it whether we like it or not. Be it ego offending, it's offensive to our ego or not. Yeah, we always speak the truth. Okay, so why? Because we have vodka. Okay. Oh my goodness, look at that. Look how pretty this coloring. This is like semi-ripe, semi-ripe, quasi-unripe, high bush cranberry. Oh my goodness, yellow, green, orange, red. Oh, pretty. They taste good too. Okay, so all right. So how do we go about this? Okay, well, we gotta use previous theorems that we postulated. Uh, okay, you M mu conversion theorem, right? All right, M mu conversion theorem. So, ooh, there's something missing here. This cannot be correct. I must have made some mistake. Okay, so let's make some examples. Okay, so no, this should be -1. I'm sorry. Okay, so and it's trivial. It comes from the MU conversion theorem. Okay, so okay. What I meant to say is this. Okay, so we have M 220 is 10 and mu 220 is 10 minus 1. Okay, so Am I showing you my bold spot? I'm sorry if I do. Okay, I am sorry. Yeah, it's ugly. I know. Okay, I don't want to show you my bold spot, and I don't want to see it either. But I'm bolding. Okay, I'm getting old. Okay, so what can I do? Right? You have to excuse me. All right. Okay. And what is absolute value of M220 union M320 is what? 10 plus 6 minus 3 is equal to 13, right? Okay, how about mu? What is mu 220 union mu 320? Absolute value of that is what? Is it like is it 9 plus 5 minus 2? 12? Is it? Then what's the relationship between this and this? Is it just minus 1 difference? That's what I'm trying to get at. Because I thought this has to be difference 2 because you are subtracting 2 and 3, so it's better have difference of 2, but it's having difference of 1. To me that seems erroneous. I must have made some mistake here. We have only 10 minutes left. I have 10 minutes to correct the error. I think in mu world they must have some different formula. Okay, so Because this is supposed to be 11, alright? So I'm having some trouble coming up with that. It's like 9 plus 4, 5 is 14. You have to subtract 2, it becomes 12, but you have to subtract 1 again. I don't know where that 1 is coming from. We may need another whiteboard, okay? I'm sorry. We may have to continue after this episode is over. I'm trying to avoid that though. I gotta peel that boiled eggs, you know. Ay. So these 13 elements, okay, set of 13 numbers, union. Subtract, you have to subtract 2 and 3, that's why it has to be 11. I'm having trouble finding that formula for this. Well, this is intersection of M22, M320, alright? Oh yeah, because mu 6, it also excludes the first element 6. Okay, so of course that's why. Okay, minus 1 is 1. Yeah, yeah, okay. So we will have to make another theorem, okay? So um, mu top ALB absolute value thereof is equal to um, M ALB T minus 1. Oh well, but that's M mu conversion theorem though. Okay, so I guess we have a proof now. Okay. We may have to continue, okay, because I don't think I can do this in 5 minutes, alright? So, but let me try to make sense of this as much as I can. We need another whiteboard, okay? Again, if you're addicted to group theory, abstract algebra, let this be some wake up call to you because we are not dealing with abstract algebra, group field ring theory. Don't be too obsessed by that, like those Harvard people or MIT people, okay? This has nothing to do with group fucking theory, fucking Galois or Abel or no. It's a set theory, okay? So don't be too engrossed, sold out by all this group theory shit, okay? So Be independent, okay? Don't follow the mainstream like a dead fish flowing down the mainstream river. Harvard, MIT. That's just followers, right? Followers of mainstream. Will shame on you. Zombies, dead people. I appreciate what they do, but just making some constructive criticism here. Followers. They just follow down the mainstream and just like zombies, just like dead fish, dead people. I think I, I think I got it. Okay, so uh, we're gonna take a break though. All right, so I think I got it after staring at this for a while. Okay, but we need to find another whiteboard. We take a break and continue in this next episode. Okay, because I think this is something important. Maybe nobody will appreciate this nowadays, but maybe some decades from now, we'll find some audience. Okay, thank you. I see you soon. I promise. Thank you. Bye.